certain equation about interest we talk about, and then we'll talk about percent change. They're all pretty quick, and you've probably seen them before, but once again, I like to re-go over everything. I use equations. Some people like to use proportions for these, where you do like part over whole equals something, percent over 100. If you're doing that, go for it. Works for me. But I usually use the keywords is, of, and what. So when I see the word is, I'm going to put the symbol equals. When I see the word of, I'm going to put multiplication. So I'm just going to put a little dot for multiplication. Is not multiplication. And when I see what, I'm going to put a variable. I was just using W because what starts with W. It's kind of crazy there. But you can use X. You can use whatever you please. So I read through it and set up an equation. If you're reading through it and just in the past you've done it with the proportions, go for it. It's just preference. But let me look at those three examples on the top. So when I see the word, I replace it with a symbol. So I would say what, that's going to be my variable because that's what I'm looking for, is, I'm trying to see what it's equal to. The big thing with percentages is when you plug them in, you do want them as decimals. So you always think about your percentage and move it 2 decimals to the left. So we would write 40% if we move it 2 to the left is 0.4. And then of is going to be our multiplication, 8. So that sets up a nice equation for me. I actually don't even have to do much solving. I just have to more do simplifying. So this is where I just grab my calculator and kind of throw that in. So that's the stuff I don't want to really do in my head because it's going to be annoying. So I'm just going to do 0.4 or 0.40 times 8. And my W is going to be 3.2. So if I ask what's 40% of 8, you would say 3.2. Percentages is one of those things you actually use. Like I use it all the time when I'm doing my shopping and you have a certain percent off or you're paying a certain percentage. The other day I saw a sale and literally it was 1 cent off. Like the original price was $3.99, it was $3.98. Now some people don't pay attention. They're like, sale, sweet. You gotta pay attention. So sometimes they give you percentages off and they're not even worth it. Mm-hmm.
So anytime there is a percent, move the decimal over 2.
You got it. Yep, you always want to make it a decimal. So let's look at the other ones because the setup is a little different. So 16, the main goal is if you know these, 16, I write 16, is, that's my key where I'm going to put equal. 25% I write as the decimal 0.25, and then of, I'm multiplying by a variable W. So we can say, oh, okay, maybe things were set up in a different order, but we did the same things. When I saw a number, I threw it in. The percentages, I made decimals, and I just used my keywords. This one I do have to solve because it's 0.25 times W, but I want that W isolated. So I would divide both sides and get that W equal. Once again, not something I really feel like doing in my head. So 16 divided by 0.25 comes out to be 64. And then the last one, same idea. What, that's what I'm finding, that's my variable. I'm just gonna underline percent. That just means I want my answer to be a percentage. So I just have to kind of keep that in the back of my mind as I'm finding my answer. Of is multiplication, 40 is 5. Okay, so then I solve for W. I grab my calc. 5 divided by 40 is 0.125. But I wanted this as a percentage. So when we're going from percent to decimal, we move 2 to the left. If I'm doing the opposite, I'm going to move 2 to the right. I multiply by 100. So if I move this, convert this to a percentage, that would be 12.5%. So those are kind of the 3 setups that we'll see as we're going through. But in general, if you know those is of what, you can basically set up any equation. Main goal is solve for the variable. And one like that third one, sometimes you're looking for percentage, so just pay attention if that is something you need. Does anyone have a question with those 3 examples? We're not going to do every problem on this. It was just kind of like, yeah. So why don't you guys try uno, dos, Beatrice. Just to see like, okay, if I were setting this up on my own, could I set up an equation? If you're doing it a way that you've done in the past, that's perfectly fine. There's no right way to do it. So if you like a proportion way that you learned in the past, go for it. But in general, even if you don't have a calculator, you should be setting up those equations. So can you try those now? Just as to make sure we're okay before we move on. Another minute, hopefully those shouldn't take too long. And see, I'm gonna kind of skip around, so you don't need to do all of them, just try 1, 2, 3 for now. See if you people still working, so about 30 more seconds, we'll come back together. Alright, so main goal, we read through, can we set up an equation, can we solve it? So I'm gonna grab my handy dandy calc over here. So I would set this up as 15 equals W times 12. I always underline that just to remind me my answer should be a percentage. So I'm doing just a quick solve, so that's not bad to actually solve it. W is gonna equal, about 12, is 1.25. And then I do need to convert this to a percent, which means I move the decimal 2 to the right. And W would be 125%. It is perfectly fine to have a percentage over 100. I feel like sometimes that freaks people out. You could have 1,000,000% if you really want. But percentages over 100 are fine. But just make sure you do that extra step of making that. Any questions on 1? Okay, number 2, 12 is, we write the percentage as a decimal, 0.15 of what, so times W. I would have to divide both sides to isolate W. So once again, the actual work, I just couldn't throw it in my calculator. And that would give me 80. Any problems with that one? Okay, W equals 0.25 times 80. So just using those keywords. And that one I just throw in 0.25 times 80. And see what we got, which is 20. Okay, so in general, are there any questions if you had to set up a percent equation, how you would do it or how we are getting the final answer? Isn't that just fabulous? Thank you. We are going to kind of, I don't know, just skip around. I'm gonna come back to those writing equations. We'll do those at the end if we have time, but I wanted to show you the stuff on the back because that I know is on your assignment and I'd rather kind of focus on the stuff I know is definitely there. And then we'll probably backtrack and do those later anyways, but just with time constraints, I'd rather get the stuff I know you needed. Okay, so we'll do maybe 1 or 2 from the top, a few from the bottom, and then we'll probably go back and do the fronts, but I'd rather not rush ourselves because this and this are definitely on your assignment on Friday, so that's why I want to get it in. So it says use the formula for simple interest And it tells me the simple formula as I equals PRT, which means a whole bunch of nothing. It's just a bunch of letters right now. So the first thing we have to do is define what the heck do these letters mean, so I know where things are going. So I'll just do it off to the side over here. When I see I, that's gonna be your interest. So what happens is we have some money, we're gonna put it in an account, it's gonna earn some interest, which is what happens when you put it in different type of bank accounts, depending on what you put it in. So we're trying to figure out how much interest are we earning, so that's our I. P means principal. Oops, I can't write. Principal. It's an awkward I. Principal is just how much you're putting into the account. So what's the original amount I'm putting in? When I open my account at the bank, we call that the fancy word for its principal. R is your rate. So at what rate am I earning my thing? That's always going to be a percentage. And T is time. How long am I keeping my money there? So obviously when you invest money, you want to make as much as possible. So maybe you'll compare accounts. What's happening right now? Depending on, I don't know, maybe where you're putting it, you're getting different rates. So this is actually something I've done in the past in my real life. So good to know where these things are coming from. So let's look at number 12 and see if, as we read through, can we label what we know, and then can we find what we need. So suppose you invested $900. So I kind of label as I go. So please don't say, oh, invested, that's I. No, it's not. That's how much I put in. So this is my principal, we call that the P. So I know what P is. For 2 years, that's an amount of time. That's my T. You earned $67.50 in simple interest. So this is my I, this is the interest that I'm earning. And I want to know what was the annual rate. So my question is, the rate is what? So I'm a labeler. I like to kind of go through and know, what do I have? What am I finding? I always find, like, just that's the way my brain works. Whatever way it works for you, go for it. But I find when you tend to label, things just kind of fall into place, because then we have that nice, oops, I'm writing it wrong. That nice formula. Why can't I write today? And I'm just gonna plug in what I know. I know I is $67.50. I know P is 900. I don't know R. And I know T is 2. So I have to do a little bit of solving. My main goal is to figure out what R is. When I'm solving this, I can combine like terms over here because order doesn't matter for multiplication. So I can do the 900 times 2 right now. That would give me 1800 R. And then I could divide both sides to get R by itself. I ran out of room there. So once again, this is not something you would never do 6750 divided by 800 in your head. So you grab your calculator. If you don't have one, you're going to get one. If you have an issue getting one, please let me know. Somewhere in the math department, there's like extra ones you can sign out, like a book. So you let me know if you need any assistance with that. And I get 0.0375. It asks for rate, and we just reminded ourselves at the beginning, rate is a percentage. So if you're ever giving me the rate, you are going to write it as a percent by moving that decimal 2 places to the right, and your final answer would be 3.75%. So it's really just, okay, we have this formula, we're going to plug in what we know, we're going to find what we don't know. That's about it. So let's look at number 13. You placed $1,500 in a savings account. That's my principal, that's how much I put in, so that's my P. It's drawing 7% simple interest. When you see that percentage, that's always your R. Right underneath, so I got out of room. How much could you expect to earn in 10 years? So that's my T. So I want to know, what's my interest? How much am I going to earn? So I is my question mark. So I just remind myself, I have a quick little formula. I'm plugging in what I know. I know P. I know R. Now P is just like with the other equations we did. When I plug in my rate, I write it as a decimal. So I'm gonna move the decimal 2 to the left, which will give me 0.07. So please just don't write 0.7. That's a big thing, that's 70%. I'll move it 2 to the left, and then T is 10. So that one's not bad, because you just kind of throw that in your calculator, you don't really have to solve much. So I grab mine, and I would get $1,050. So that's not bad. So if I just had this $1,500 sitting around and I wasn't gonna spend it, you might as well throw it in a bank account, because after 10 years, I know that's a long time, but it's better than just sitting in a drawer, because you did make some interest off of it. So investing is a good thing, because it makes you money. So why don't you try 14? So if I said, hey, I'm gonna give you this problem on simple interest, would you be able to set it up? If you don't have a calculator right now, you should at least be able to set up the equation and do your best to solve it. Why don't you try that one? And if you need any help, you let me know and I will come and help you.
So yes, under coverage, we've undercovered okay. By the way, I not bias.
So just try 14 and we'll just kind of try one and see how we're feeling.
All those people that didn't respond, probably don't really care how to type.
Yep, go ahead, just start the passage. Two more seconds, I just don't want to rush you.
Not respond bias, the people that don't respond might all do the same way. So notice the shirt that we have. How is this possible? Fine.
All right, so let's look and see if you set it up okay, if you had your calculator, if you solved it. Hopefully you're noticing you need a calculator, so please get one. You invested 2,100, so that's gonna be my P, how much I put in. For 4 years, that's my T. You earn 312 in interest, so I know I, and this one I'm looking for the rate again. So it just depends what you're looking for depending on the problem. So my equation, I would put I in equals P times R times T. Just like in the other one, I can kind of combine those because with multiplication order doesn't really matter. So 2,100 times 4, I can just leave that in order. Put that in wrong, 2,100. You use a calculator, make sure you're using it correctly. Equals 8,400 times R, and then I would divide to get R by itself. And R is going to equal 8,400. 0.037. I mean, I know it's really long. We'll just go out a few decimal places. And then please remember your rate is a percentage. So we would say this was about a 3.7% rate earning account. Does anyone have a question about how we set that up, or how we simplified, or anything of the sort? Fabulous. Okay, so that's kind of the second thing. So the first thing was percent equations, like is of what, how do we write them? The second thing, if it talks about simple interest, we're using that formula. But it's not too terrible to plug into, it's not too long or anything too complicated. So it's just knowing what goes where. And the last major thing that you just need for Friday is called percent change. So we will talk about that, and then we will take a little break, and then if we have time, we'll go back and try those other ones. But if we don't, it's not the biggest deal. We can do them later as we kind of continue to move on with stuff. I just know that this is the stuff you need. Okay, so last major thing that you need for your assignment is percent change. So to find the percent change of something, you are going to find the difference in the values and then you are going to divide by the original value. So what kind of thing, well, that means a whole bunch of nothing right now, so I'll tell you what that means, kind of with some numbers. But for now, at least write it down so you have something to refer to. So an example, the number of animals at a zoo is increasing. They started with 12 animals and it's increased to 26. I want to know what's my percent change. Okay, so when I say find the difference in your values, that means subtract the numbers. Difference just means subtract. I'm always going to do it, so I'm subtracting the larger number minus the smaller. I don't want negatives, so the order there doesn't matter. Always do the larger minus the smaller. So difference just means subtract them. And then we're going to divide by the original. So how much did they start with? They started with 12. Just be careful with your calculator. As much as they are our friends and they do the work for us and we love them, if we tell them to do things incorrectly, it's a hot mess. You can't just write 26 minus 12 divided by 12, because then it will divide before it subtracts. Well, yep.
Wait, where did you get the 12 underneath from?
The original value, there was originally 12 animals. It's basically usually just your first number.
Oh, okay.
Okay. So I kind of do it in two steps. I grab my calculator. I do 26 minus 12. That comes out to 14. And then I divide 14 divided by 12. We're fine. I know I'm usually against decimals. It's a character flaw. But for this, we do want decimals. So I'm going to go to 3 decimal places, 1.16. I'm going to round it to 7 because it's 6's repeating, but we don't need the whole thing. We'll just go to a few decimal places. Okay, so the work wasn't bad. Just as a reminder, we want a percent, so we're going to move the decimal 2 to the right. So we're going to write that as 116.7%. And then we always want to say, is it an increase or a decrease? So just think about your numbers. It went from 12 to 26, so my animals are increasing. So you do this a lot, like if you ever get a job, like and you maybe get a pay raise, you want to check your percent increase. Once again, people try to trick you, like you think it's a lot, but then when you do the percent, it's actually not that much. That's something I've seen in actual real life quite a bit. I'm talking about percent increase with pay. So you want to know what's fair. So let's look at one where it's a decrease. The amount of donuts in the bus, I'm so hungry right now, went from 12 to 5. What's the percent change? Okay, we do the same exact thing. We find the difference in the numbers, we're going to subtract them. I don't want negatives, so you always do the larger number minus the smaller number. You're dividing by the original. The original is just what I started with. I started with 12. So that's basically the setup. I grab my calculator. 12 minus 5 is 7. So I kind of do it in 2 steps. 7 divided by 12 gives me 0.583. So let's always go to 3 decimal places to the thousandths, just to be consistent. But I remind myself I want a percentage, so I move the decimal 2 spots, 58.3%. And I'm always going to say, is it an increase or decrease? Just think about your numbers. I went from 12 to 5, which means there is a definite decrease in the number of donuts. So when you see percent change or percent increase or percent decrease, That's kind of the idea, or the setup. So once again, hey, if you don't have this memorized, I don't blame you because we just learned it. So on Friday, as you're working, you're like, oh shoot, I forgot how to do that. Just grab all your worksheet and look at what you did and look at some examples. That's why we do notes, to use them as a reference. Or you can always ask me a question too. I'm happy to answer. So before we take a little break, we'll do that in a minute or two. Why don't you guys try 16, 17, 18, just because I can see those ones. So if I asked you, can you please find the percent change of each of those? See if you can follow your steps. Once again, if you don't have a calculator, at least set them up. And if you have any questions, let me know. I'm trying to give you, people have said they need a little bit more practice time, so I'm trying to let you at least practice each type of problem on your own.
Five questions.
Huh.
5 questions. Or-
A few seconds.
How are you doing here,
It gives me a heart attack. Okay, so let's kind of see, or just be okay with the setup. We're just throwing in a calculator. So once again, doing the actual computation shouldn't be bad. It's just making sure you're putting it in the right spot. So I'm going to subtract those two numbers, find the difference. I don't want negatives, so I'm gonna always do the larger minus the smaller. I'm dividing by the original, which in this case will just be the first number given. So I do 175 minus 100. I can do that by how much? 75. And 75 divided by 100 is just 0.75. And then I convert that to a decimal, to a rate, a percentage, I can't even talk anymore. That would be 75%. I went from 100 to 175, so that is an increase. Any problems with 16? Okay, you guys know how much I hate decimals, but I'm gonna just say go with a decimal here. You can make this 36.5, you can make this 29.25, why not? I'm gonna subtract them, I'm just gonna do this one right in my calculator. So I'm gonna do 36.5 minus 29.25, and I'm gonna divide by the original of 36.5. That's gonna give me about 0.19, I'm gonna round it to 0.199, because it was 0.1986, so above 5 we round up. And then that would be a 19.9, if you said 20%, I'd give it to percent. We're going from there to there, so that's a decrease. And then last but not least, I'm just gonna do this one in my calc too. I'm going to subtract those two numbers. I'm going to divide by the original, and I'm going to get a that would be 0.129, but that would round up, so I'm just gonna round to 0.13. That's gonna be a 13%, and that would be a decrease. And that's, my friends, is the main idea behind percent change. I actually do percent change a lot with people's grades too. Like, are you struggling? Are you going up with your grade? Try to ask people. So are there any questions with any of those general ideas? Writing percent equations, using the simple interest formula, or finding percent change? All right, we only have 5 minutes left, so you can put that away. We'll do another little quick roundabout and see. Close it.